So 1.2, we have vocab down. Okay, we have some stuff written down. There wasn't a lot, and a lot of what we're going to talk about today should be kind of common sense sort of stuff. So it just kind of makes sense, right? And if it doesn't, that's okay. All right, we'll talk through it. But the reason why it's going to kind of make sense is let's look at the definition of a postulate. Okay, definition of a postulate is a rule that's accepted without proof. So this is something we just accept to be true. Like nobody needs to tell us why. We just know that it's true. The most basic postulate out there, or axiom is another word for it. I don't really use axiom, I use postulate. The most basic postulate out there that you guys use without even knowing it is the fact that 1 + 1 is 2. We just accept that. Nobody has to prove that to us. We know that you got the number 1, and then the next number is number 2, right? Like we just accept that. So we're going to go through these postulates, and we're going to see a few of them at the start of the year. We'll see them a little bit throughout, but most of them are highlighted in the beginning of the year. Where, yeah, that's common sense. Yeah, I know that. Why are we even talking about that? Right? So that's the sort of stuff that we're looking at with postulates. But the reason why we do it is because we always have to give a reason why for certain things in geometry. And so these postulates are going to become our reasons why. Why can we do that? Well, we've got that postulate that says it's true. Okay. So our first postulate, this is definitely one of those common sense ones. In fact, if you read through this, you might even be confused as to what it's trying to say. All this is saying, guys, is we can take a line, we can take a line segment, and we can assign a length to it. We can say that this line segment here is longer than this line segment here. Right? We can treat it like a ruler and measure. That's what it's saying. Okay. We can treat a line, we can treat a line segment like a ruler and measure. Okay, how long, how far between different points. That's really what we're looking at. Okay. And then we get this word distance, and we all know what the word distance is. But the biggest thing that I want to point out about distance is the fact that it says absolute value. Why does it talk about absolute value in terms of distance? What does that matter? Yeah.
Because you can't have negative distance.
Exactly. You can't have a negative distance. So your distance is always going to be positive. A length is always going to be positive. That's why they throw that absolute value. Just to say, yep, it's going to be positive. Okay. You can't run -5 miles. Right? You can't run, or you can't have a pencil that's -2 inches long. You can't have a negative distance or a negative length. It has to be positive. Okay. So what we're going to do with that ruler postulate, that being able to measure distances, is literally measuring distances. That's what we're going to do. Okay, so you're going to see some problems on big ideas where they're going to give you a segment, and then they're going to give you a tool, a ruler that you can drag around the screen, and you're going to have to measure the length of that segment. Now, a couple things to point out here. Notice that they are not measuring starting at 0. You don't have to measure starting at 0. All you have to do is subtract the two numbers where those points are. Right? So in this example for ST, you got a point at 2, you got a point at 5.4. We can subtract those two numbers and get our distance, our length, 3.4. Or we could have slid that ruler over, started at 0, and would have gone up to 3.4. Either way. Right? But we don't have to start at 0 when we measure something. Just make sure you're subtracting. Now, when you get to big ideas, you get to the homework, these problems are going to be frustrating to you because we typically, right, would line up that dot right in the middle. They're either going to line up that dot slightly off this way or slightly off this way. You're going to think the answer is 3.4. They might say the answer is 3.2, right? Just because it's weird and big ideas. Don't get frustrated with it. It's somewhere, work with somebody around you to guess the points around it. Okay. Now, if your answer is supposed to be 3.4 and you're getting like 5.8, you did something wrong. Okay. But if you're like 0.1 off, fine. Don't worry. Any questions about measuring using a ruler, anything like that? Awesome. So another one of your words that you had here was construction. We're not going to do a construction in this section because the one that they have is very basic and it's not worth our time at this point. We will get into constructions tomorrow, I believe, is when we start doing construction. That's where we're going to use the compass. We're going to use the protractor, that sort of stuff. So if you have that of your own, please bring it tomorrow. We will use it tomorrow. Okay. All right, so we will get into construction tomorrow. That construction is just making something, right? Building something. So we will look at that a little bit more tomorrow. For today, we're going to concentrate on this idea of congruent segments and then our second postulate. So congruent segments, first of all, we look at a lot of stuff to point out here. The definition of congruent segments are segments that have the same length. Have the same length. Okay, we can measure if they have the same length. Now we're going to see that in different ways. You will see where we do it on the coordinate plane. We'll look at that in a couple minutes. But we're just talking in general right now. If they have the same length, they're called congruent segments. One way to visualize or visually represent that two segments are congruent is by this little mark on the segment itself. Those are called tick marks. Okay, tick marks like that. And tick marks just show us in a picture that two segments are the same length. They are congruent, guaranteed. We don't have to measure because they are, right? So if I have that, let's say I have this figure here, something like this, right? Now that I have some segments that have one tick mark and some segments that have two, that's telling us that these two are congruent and these two are congruent, but they're not congruent to each other. So you got to kind of match up the tick marks to see which ones are congruent. And if they have a different number of tick marks, they're not congruent. That allows us from when we start drawing a picture, we don't have to measure it out using a ruler or anything like that. We can just throw those tick marks on there and everybody knows those are going to be the same one. Whether or not you grab a ruler and they actually are, doesn't matter. Because those tick marks are there, they're the same. Other things to point out here, the congruent symbol. Make sure we know the congruent symbol. It's that equal sign with the little squiggle over the top. That is the congruent symbol. Anytime we see that, we will see that a lot this year. It's that congruent symbol. Now, one thing about this that's a little tricky to understand at the start is the difference between when are we going to write it like this and when are we going to write it like this. One with an equal sign, one with a congruent sign. So I'm going to try my best to explain the difference, and then as we go, we'll keep pointing it out, keep talking through it. It depends on if you're talking about the length or the segment itself. The length is the number value, right? The length of it is the numerical value of that segment. This is 4 long, right? This is 10 long. If we're talking about the numerical value, the length of them, we say that those are equal. And when we talk about the length of AB, so the distance between point A and point B, we just write it as AB. We do not put the bar over it. So anytime you see two letters right next to each other like that, that is the length of AB and the length of CD when it does not have the bar. When it has the bar over it, we're talking about the segment AB. We are naming the segment. We're not talking about the length of it. We're naming the segment itself. So segment AB and segment CD are congruent. Lengths are equal. Segments are congruent. Lengths are when we don't have the bars. Segments are when we do have the bars. So they kind of go together. If we're not going to put the bar, we're using an equal sign. If we are putting the bar, we have a congruent sign. We're going to work through it. The more we see it, the more we get used to it, and we'll know when to use what. Okay. All right. Any questions on congruent right now, or any of those things that we just talked about? Okay. Moving on. Part of what you're going to see for that, like I said earlier, is they are going to give you some points on here to graph on a coordinate plane and then tell whether they are congruent or not. All right, well, all you're gonna have to do is you're gonna have to create that graph online. Right, you're gonna create that graph, and all the line segments that you create today are either gonna be horizontal or vertical. Horizontal or vertical, so nice and easy, we can simply count the number of boxes to the other point. And that's the length. Don't worry about what they're doing here with the absolute value, just count. Okay, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Lengths are the same, those are congruent. Okay, nice and easy on that. Tomorrow we'll see what happens when they're not vertical or horizontal. How can we find the length? That's tomorrow. Okay, today nice and easy, horizontal, vertical, simply counting your boxes. Okay, moving on. The next vocab word, the last vocab word that we had is the word between. Now, before today, before this lesson, so think back, your younger self a couple days ago. If I just asked you a couple days ago, is B between A and C? What would you say? Yes. Mathematically speaking, is B between A and C? No. So raise your hand and tell me, what does it mathematically mean to be between? What's the difference here, please?
For one point to be in between 2 points while being on the same line as the other.
There you go. Yeah, it's got to be on that line that connects them. All right, so for B to be between A and C, mathematically speaking, they need to be collinear. They need to be on that line together. Okay. Now B is between A and C. So we're going to see that throughout the year where there are some words that we think we know the meaning of, but mathematically speaking, it's slightly different. Okay. All right. The reason we bring that up is because in our postulate, it uses the word between. This is one of the most important postulates that we have this year. We're going to use it over and over. This is the segment addition postulate. And again, this is common sense stuff. This is I could show you some of the questions and you would already know how to solve them, but we give it a reason why. Okay, this is saying if B is between A and C, we can add up the length of AB plus the length of BC, and it equals the length of AC. To give it numbers, if AB is 8 and BC is 4, what is AC?
12.
12. Right? We know that. We can do that. That's what this postulate is solving. We add up the two smaller segments together, it equals the bigger segment. So like I said, it should be kind of common sense for us. So when we see our basic problems like this, we should be able to get those answers pretty quickly. The person next to you about these two answers here, please.
For D plus
58, and then the second one,
Yeah.
the length between GH would be
All right, what's our first one? What's our first one, Claire?
58.
58. And what's our second one here, Jack? 15. 15. There you go. Right? So on this one, we're just subtracting. We take the whole thing, subtract the 21, and we get what's left here, which is 15. So those are our basic, nice and easy versions. It's a little bit harder when we start doing something like this is 6x plus 20. This is 3x plus 10, and this is we'll say this is 6. And we have to solve for x, right? So this is where that equation comes in, where we can take this plus this equals the whole thing. Okay, we're going to create that equation, and then it's some algebra, and we can solve it out. So that equation that we would create here, right, would be 6 plus 3x plus 10. So the two smaller segments added together equals the whole big segment, right? And then we can solve it. Why don't you go ahead and solve that? Let's just double check. Let's make sure that we can get it. Remind ourselves of some algebra here. Alright, so we have here, we gotta combine like terms first, right? So you got 6 and 10, we can add together. That's 3x plus 16 is equal to 6x plus 20. The variables together on one side. Subtract your 3x. 16 is equal to 3x plus 20. Subtract the 20, gotta get rid of the addition, subtract it first. That's -4 is equal to 3x. Divide by 3, x is -4.
Let's go.
So that's algebra. Chapter 1. We have to, I have to assume that you know how to do algebra to be able to get through this class, okay? So if you're struggling on this kind of stuff, that's fine for now. Maybe you didn't look at it at all this summer, whatever. You've got to get back into it. I need to be able to just say, solve this out, and we get the right answer every time. Okay? I can't, I'm not gonna reteach you all the algebra stuff we did last year. I can't. We have so much other stuff to do. Okay? If you need help in the algebra stuff, I'm more than happy to help. Come in during, or ask me during homework time, flex before after school, whatever. Okay? But moving forward, I'm going to assume we know how to do algebra. Okay, like, talk to you guys algebra. All right. Or Mr. Cross. All right, so that's segment addition function. So the only other thing I want to show you with it is you might see a word problem here. But again, it's common sense. We know what to do in this situation. Right? If I just showed you this and I said, all right, it's 738 miles here, 377 here, how would you find this? What would you do, Claire?
Subtract 377 from 38.
Yeah, so a 738 minus 377, right? There you go. We would subtract those two and we would get it, okay? Now, you are going to see some of these types of problems where they don't give you the picture, right? They just explain it in words. If you're ever unsure, then you need to sketch it out, okay? Just draw out a picture nice and quick, okay? Put the different number of miles to this point, this point, or whatever it is. The other thing to be on the lookout for is the phrase round trip. What does round trip mean?
Both ways.
There and back, okay? So in this example, right, maybe they said it's 377 from Lubbock to Tulsa. From Lubbock to St. Louis, it's 2,000 miles round trip. Well, if it's 2,000 miles round trip, that means one way it is 1,000. Right, and then we can subtract into that. Okay, so just be aware of those, of that phrase, because you will run into it. Okay, any questions about it? No.